Anyway, okay. So here's what we're going to do. We're going to do distributed data collection, and then we're going to have a coffee break, and then we're going to do the Fragile Families Challenge. Okay. So distributed data collection. So this is the third main area. So first we had these human computation problems that were easy task, big scale. Then we talked about open call problems, where the difficulty comes from not even knowing how to approach the problem. And so you want to be open to many new ideas. This is especially useful if the problem has solutions that are easy to check. Distributed data collection is a third area that involves sort of allowing people to bring in new measurements to you. So one way of thinking about the difference between, sometimes people ask human computation and distributed data collection, how are they different? So for example, if someone is adding labels to an image, you could call that data collection as well. So the way I like to think about it differently is distributed data collection involves not people annotating data to existing measurements that you have, but providing new measurements. And this, having people provide new measurements about the world, introduces a number of different problems that can arise. So I think a lot of opportunities for distributed data collection come where people can be where researchers can't. So some of these challenges are logistical, like you can't be everywhere. Some of them are really, people can be where it's not safe for you to be. There are a lot of other times where there are settings where you just can't be where you need to be to collect the data. And you can't necessarily hire someone to be where you need to be to collect the data. It potentially offers a scale that researchers can't match if you have people all over the world working together on this, like eBird. And as I said, it's sometimes hard to separate from human computation, but I think the big difference is the new measurements from the world, particularly in a setting where people can be where researchers can't. Okay? So I want to give people, when they hear about distributed data collection, their first thought, if they're social scientists, is always data quality, right? How can this be possible? This is going to be garbage. That is a very good first reaction. But now I want to give you an example of a project that uses technology in a way that gives us more confidence in the quality of the data and also standardizes the data collection some. So we had a question earlier about if we have people labeling texts, how do we know if there's some sort of potential liberal or conservative bias in the way they do those labels? So imagine now if instead the data collection is done through a piece of technology where those concerns don't become so important. So who is exactly contributing is less important than what they're contributing. And this is an example called PhotoCity. So the one way to think about where this project came from is there was an earlier project that was called Building Rome in a Day. And so they had this cool idea that there are all these pictures online. And so what if we take all these pictures that people post online and use them to recreate 3D images of Rome? So they tried to get all the images of Rome they could find online and then put them all together to recreate these 3D models. And so here you can see a reconstruction of the Colosseum, and these are the angles that the pictures are being taken from. So one of the things they found is that many people who are taking pictures of the Colosseum turn out to all take the same picture. It's like same angle, same. So if you want to create a 3D reconstruction, you need to have some way of getting people to take pictures of other parts of the building. And so what they did is they started this project called PhotoCity, where they tried to reconstruct buildings on the campuses of the University of Washington and Cornell. And so they set this up as a game where they had these flags on the different buildings, and you could go and take pictures and win flags, and there's teams and points, and it's a bunch of trying to make the data collection and participation enjoyable. And then people would upload pictures, and these are the results of the reconstruction. So I want to talk a little bit about how the structure of this enables a lot of confidence about the quality of the data and how I think that will become increasingly possible So the way these reconstructions work is the researchers uploaded a very small number of seed images of each building. And then the pictures that participants contributed were matched against those pre-existing seed images. And if they didn't match, they were rejected. So you can see how redundancy enables you to assess data quality. So they put in a small amount of data that they knew was true, and then they're able to use redundancy and overlap as a way of ensuring data quality. So you don't need to just totally trust what everyone is doing. Redundancy can be your friend to assess data quality. The second thing about this is that because people were contributing images, all of the data was standardized in the sense of it didn't matter if you were, in eBird, for example, there are big questions about variation in participant quality in the sense of some people are really good at separating like a bald eagle from like a red-headed hawk or something, and like I'm not good at that. And so like I could be uploaded, like that bird right there, I could upload that to eBird as like a crow, and it might not be a crow. But if I was just taking a picture of it and uploading it, then that de-skills the process of contribution. And so here, what they've done by having people use these cameras is they've de-skilled it. And so anyone with a camera is able to participate. And now, many people have cameras on their smartphones. So many, many people could participate in a project like this. So it's a beautiful design that solves lots of problems. As I said, the standardizing the data collection means de-skilling, which increases the number of people that can participate. The verification is automatic by comparing to nearby images. And the other thing I love about this is that they help people contribute more valuable information using the scoring system they have. So the number of points that you get for your picture is related to the number of pixels that it adds to the reconstruction. And so over time, they're teaching the respondents how to contribute better and better data. And so eBird does this as well, where they train people about what different birds are. And if you upload something like, I just saw a bald eagle on Duke's campus, they will potentially send you a message saying, we think it's unlikely that you saw a bald eagle on Duke's campus. So they are trying to like upskill the participants. And I think here the scoring mechanism does a great job of doing that so that people can contribute as much information as possible. You're helping them contribute important information. So any questions about distributed data collection?
So I can see that you're able to download data from eBird. Do they have data on like how many like moments there are when someone says that's a bald eagle and it's a crow or something?
Yes. Okay. So let me talk a little bit about eBird, the data verification process, and then the analysis process. Because eBird has a problem that I think many distributed data collection systems will have that you need to be aware of. Okay, so first, as soon as something is uploaded to eBird, it gets compared against a database of sort of historical known sightings. So if you say that you see a bald eagle here, it will say that seems unlikely, and it will send it right away to an editor, a volunteer editor who's a local expert. Another problem is that people sometimes say they see things out of season. So like, I don't know what kind of birds are usually here in the summer, but the birds that are here in the summer are potentially different than the birds that are here in the winter. And so there's enough historical data that you can create a flagging system. Those things get sent to a local volunteer who then goes back and forth with the person who made the submission. This is a very important process, though, because one of the things they're interested in is changing migration patterns. And so let's say a bird that is usually here in the summer shows up here in March. So is that like an outlier, or is that incredibly important information about changing migration patterns? And so having these local experts involved is very important. So then the data gets in there, and then there's another problem, which is that if you look at eBird, almost all of the birds in the US are near roads. So there are no birds where there are no roads in eBird. And this is because these bird sightings are done by people, and so they are mostly near places where people can go. And there are certain parts of the US that are hard to get to, and we don't have any good measurements of birds there. And so there are a number of ways that you can try to deal with this. So they have built different kind of statistical models to try to adjust for this. It's a huge problem. Anytime you have people contributing data through a distributed data collection, you have to realize that it's going to be limited by where the people are. Another problem they have is that different people do birding in different ways. So some people only write down like whether they've seen a bird, like have you seen a bald eagle on your walk today? But they don't write down how many bald eagles they've seen. And so they want to encourage people to do exact counts, not just I saw one or I didn't see one. Also, it turns out some birders tend to only report the exciting birds that they've seen. And so like where I live, there's tons and tons of geese. So if I was out doing bird, I'd be like getting exhausted, writing down every single goose that I saw. And so they try really hard to encourage people to also report on the species that are very common, because obviously that creates, it's important for the data as well. So there are a number of things that data quality issues that can arise. They have a bunch of mechanisms for dealing with them. And then they have a bunch of statistical models to try to correct for the problems that exist in the data collection. I should also say that eBird is a system that has been running for many, many years now. It has many, many researchers involved. It's a huge project. And so if you start a distributed data collection, it's not going to have all of those safeguards initially, right? So this is all stuff that they've sort of developed over time. So don't expect your distributed data collection to have all of that infrastructure at the beginning. Another thing about eBird that I think is really nice is that they take advantage of stuff that people are doing anyway. So in Photo City, they really try to encourage people to do something they wouldn't have done already, take these pictures of buildings and upload them. eBird is able to take advantage of stuff that people are already doing and enjoying. And so to the extent that there's stuff that people are already doing that is creating meaningful data, that makes your distributed data collection process easier. Okay.
So I think one way to validate this data is to have an expert check each piece of data. So in the case of reconstructing Rome, the true images act as experts. Mm-hmm. And in that case, it works out because you can take images from different directions and make sure that you have images from all different directions so that every image that's uploaded has an overlap with the true image. Mm-hmm. So if we're going to take expert validation as one way to make sure that the data, the quality of the data, how is it possible that every task can be divided into small pieces that can be validated by an expert without the expert actually checking each individual data set that's uploaded online individually?
Yeah, so I think it's a good question about, so one way to ensure accuracy that I talked about is redundancy between non-experts. And another way is to have experts doing spot checking or more systematic checking in the way that they do in eBird. So I think that is, let's say that you believe that your distributed data collection system is producing high quality data and other people might not believe it. And so then I think doing a sample where you have experts check a sample of the data is potentially a powerful technique to, one, convince yourself, and two, to convey that to others. So what's the right role for experts in checking in distributed data collection? I think that's an open problem, but I think that is another good way of ensuring quality.
Is this work? Yeah. I was wondering about like the ethics of this if you do it in a social science application, like making regular people go out into the world and report on each other and observe like social behavior.
That's a great question. So a couple of things. One is we're not making anyone do anything. I wouldn't recommend making anyone do anything. what you're doing is creating a way for people to participate if they want. Now, the examples that we've talked about so far are eBird is reporting on birds. This Photo City is taking pictures of buildings. So in social science, you may want to have people collecting data about other people. This does raise questions about consent, for example. So the people who are reporting the data are consenting to participate. The people they are reporting about are not consenting to participate. I think this would have to be handled on a case-by-case basis. But I think you definitely don't want to have a system where people are out and spying on each other in a massive way. So I think that's important. In the section about designing mass collaborations, I talked some about how we want to be ethical when we design our mass collaborations to our participants and to our non-participants. So I think in general, we all want to be ethical. But when we do mass collaboration, there are a number of issues that arise that are a little bit different. And so I think we should definitely think about the ethics of these things carefully as we're creating them. David?
Talk a little bit about the people who choose to participate in these stuff. So with eBirds, this is probably not such an issue, but there are cities, for example, that you have a smartphone app where you can report potholes and other things, and then the city government responds by fixing it. But when you look at who the people are who report these things, it tends to be affluent neighborhoods. And so that can actually redirect resources of the city just by who chooses to participate.
Yes, absolutely. So if you're going to have a distributed data collection looking for, let's say, potholes, and if the people who report are different than the people who don't report, you're going to get a distorted view of what's happening in the city. And then if you, as a decision maker or policymaker, are not aware of that, then this will introduce problems. Now, I will say that there is, in that particular case, there is a way around it, which is that people have built pothole detecting machines that you can add to a car. So if you go over a pothole, it creates like a particular signature of the movement of this box. And so they have then attached these boxes to a bunch of city vehicles that drive all over the city. And so then they can mitigate this problem. So in other words, moving stuff from active human participation is potentially subject to these kinds of participatory biases. If the data collection can become more passive, as in just put this box on this city car and enough cars cover the city, then you can potentially mitigate some of these. So I think moving more to passive versus active will help us mitigate some of the participation biases.